Hello everyone. This is in continuation to our discussion on non-parametric tests. This is Wilcoxon Signed Rank Test. How to use this, we'll understand through a numerical example. Consider the following question. Consider that the following 10 participants underwent a treatment. We measured their scores before and after. These are the scores before, these are the scores after. Totally 10 participants are there. Question is, test whether there is any significant difference between paired observations. First, we will write down the hypothesis, H naught. There is no significant difference between paired observations. H1 will be there is a significant difference between paired observations. Now we'll make the 0 and 1 as suffix. Now we need to find out the difference between these scores. So for which what we will do, we'll create one Excel sheet. This is the Excel sheet. So here we will be finding out the difference, that is after score minus before score. So this minus this. We will drag the formula to all those. Next is we need to find out the absolute difference, means modulus of. So absolute value of this number. We'll drag that formula everywhere. Now we need to find out the ranks. So for finding out ranks, we need to arrange this in ascending order based on absolute difference. So sort this absolute difference, smallest to largest. So we got it now. So now for the first two, means first rank and second rank, you are having the same difference. So we will be taking the average of first and second, which is 1.5. This one also 1.5. Then we have third rank, fourth rank, fifth rank, sixth rank. All these are shared between these 4 participants. So everybody will be getting the common rank, which is 3 plus 4 plus 5 plus 6. Whole thing divided by 4. We will get 4.5 common rank for all these 4 participants. So now 3, 4, 5, 6 is already over. Next rank will be 7th rank. Then next rank will be 8th rank. Again, last 2 participants are sharing the common rank. So 9 and 10 are shared, which means 9 plus 10, which is 19. 19 by 2 will be 9.5. So that will be the common rank for last 2 participants. Now the sign. So here, sign of this difference. So wherever it is negative sign, you will get -1. Wherever it is positive sign, you will get +1. Let us drag this. Now signed rank means rank multiplied by the sign. So this into this. Now drag that. Now first one is negative rank. So here we will be copying that. Then next one is positive rank. We'll be copying here. Let me drag positive ranks. Next one is negative. So I will copy here. Next one is positive. Next, all the things are positive. So I will drag it. Now let us calculate sum of this. So now we will also bring in absolute value, because in the next one, if I calculate it, I will get the negative value, next column. So for that, I will bring in absolute value of this sum. So absolute value of the sum, here it is 6. Now entire data is ready. I will copy this data to our, Word file. So let us go to that Word file where I copied. So we can now notice that we already copied. Now we have the calculated, we have to now proceed with, so what we did for the tied ranks. For tied ranks, we use the average rank. For example, there are two values with absolute difference of 1. So they both get the same rank, that is 1 plus 2, because they are sharing first and second rank, divided by 2, so it is 1.5. Similarly, there are 4 values with absolute difference of 2. So they all get the same rank, that is, see, you may notice that those people are sharing third rank, fourth rank, fifth rank, and sixth rank. 3 plus 4 plus 5 plus 6 divided by 4. So that will give you 4.5. That is the reason we put 4.5 and 1.5 over there. Now, sum of positive ranks, which is called as W plus, that is already being calculated by us. It is 49, sum of positive ranks. Then sum of negative ranks, which is W minus, that we already calculated and got it as 6. So Wilcoxon's test statistic, which is W, and that is nothing but minimum of W plus, comma, W minus, means minimum of 49, comma, 6, which is 6. That means our calculated value is 6. Now, we need the table value. Let me go to the tables. Here we have to see for n equal to 10, for 0.05, it is 8. So let us go back to our Word file. We will write for n equal to 10 pairs at alpha is equal to, that is the level of significance, 0.05, two-tailed. The critical value is 8. Now we can come to our inference. Since our W, which is 6, is less than the critical value, which is 8, we reject the null hypothesis, which means we accept alternative hypothesis. Let me underline this. We accept alternative hypothesis. That is our solution.